Hi everyone, welcome back to the channel. This is Rosario Borgesi and in this tutorial we will see how to deploy and interact with an ERC-721 smart contract on the Abstract chain. We will see how to mint NFTs and also how to call other functions. We will use Hardhat and zkSync-Ethers along with TypeScript. So let's get started. Let's start by giving an introduction on Abstract, which is a layer 2 rollup built on the ZK stack, which means that it is a ZK rollup, a zero knowledge rollup, but in particular, it allows us to um, write smart contracts in Solidity and also to use the libraries we are used to when dealing with smart contracts in Solidity, like VM, or for example the tools like Hardhat or Foundry, or libraries like Ether.js, and so on and so forth. So this is the Medium article that I have written for this video, and um, we will write we will create a new project with Hardhat, and so we will see how to compile and to deploy and also to interact with the NFTs. The NFTs, for those one who don't know, are based on the ERC-721 standard, which is defined by Ethereum, and you can find it here. So it means that it has a set of methods and events that this smart contract must have. The first thing to do to get started with our tutorial is to, if you are on Windows, to install WSL2, and also we need Node.js 22. If you want to set up Node 22 in your machine, you can use npm, like it is explained here. But I am on Windows, so I will use WSL2. So let's start by creating a new terminal, opening a new terminal. Let's create a new directory. Let's call it Abstract Demo, and also let's change directory. Okay, perfect. Now the first thing to do is to create a new Hardhat project. So we will run npx Hardhat init. Okay, we will choose to create a new TypeScript project, project root. Okay, I will leave everything as default. So now it will install all the dependencies. Okay. Once it has finished, now we need to install all the dependencies to compile, deploy, and interact with our smart contract on Abstract. When earlier I said that it allow this ZK stack allow to create new blockchains which are EVM compatible, it's not totally true, because even though you can write your smart contracts in Solidity, the bytecode that you will generate will be different from the bytecode that is generated with the Ethereum EVM. So let's write this. Let's install these dependencies. So as you can see here are that zkSync, zkSync-Ethers, and also Ethers version 6. Okay, perfect. Once it has finished, we could also install the .temp library to so that allow us to manage the environment variables. Okay, perfect. Now we can open our repository. I will use VS Code, but of course you can use Cursor or whatever. We need to add a new file here in the root called .env, and we put inside of it the private key of our address. You can take the private key of any wallet, any address of a wallet you have created, like MetaMask, Coinbase, whatever you have. Of course, don't share it with anyone, and don't put real money in it. Another thing to do that will be useful to deploy our smart contract, it is to get some test ethers on abstract chain. So the abstract Sepolia. So the first thing to do it is to connect your MetaMask wallet to this chain. I have already done it. So as you can see, this is my abstract testnet. I have already created a new custom network and added all these informations here. And the second thing to do, it is to get some test ether on our abstract chain. You can do this in two ways. The first one is to use an abstract testnet faucet here. The second one is to use a bridge. So you have to first get the test ether on Sepolia and then bridge them, so move them to the abstract testnet. The next thing to do now is to modify the Hardhat configuration. As you can see here in our document, I have reported that this is the configuration that it is provided by Abstract. So we can copy and paste this configuration here and put it inside this file. Here we are also adding, here we are defining both the testnet and the mainnet, but we will only use the testnet in this video. And of course, here we are importing the private key that we have written in our .m file. So the next thing to do is to install the OpenZeppelin contract, because we will use the OpenZeppelin contract in our smart contract. We can do so by installing at OpenZeppelin/contracts. Okay. Once this has been done, we can also create a new file. We can delete this. We can create a new smart contract. Let's call it cars nft.sol, for example. Okay. And here we put the code that it is reported in the document. So it is a very simple smart contract. It inherits from the ERC-721. It is also enumerable, so we can query the total supply of NFTs that have been minted, and it also inherits from the ERC-721 URI storage, so it allows us to store the token URI for each NFT. And of course here there is each NFTs, it has an auto incremented ID. So with each new say minted NFT, we increase the token ID. And this is pretty much standard. You can create this very simple manner by going to o- um, OpenZeppelin wizard here, and you choose, for example, ERC-721 token name, my token. If you want to put a base URI, you put here all the feature you want. For example, auto increment ID, enumerable URI storage, and you get a smart contract very similar to the one we are using. Okay, now we should be ready to compile our smart contract. Before compiling, we can run this command npx clean to to clear any existing artifact. Okay, then to compile our smart contract, we can run npx compile, and here we set the network abstract testnet. As you can see, it is using zkSync as the compiler, while the um, normal compiler for Ethereum it is Solk. So we are using another compiler because, of course, as we said earlier, the bytecode generated for this EVM is different from the bytecode generated for the Ethereum EVM. Now let's create the script to deploy our smart contract. Let's create a new folder, deploy. Let's create a new file, deploy.ts. Okay. Here I paste also the code that we have in the article. So basically this code connects to our wallet with our private key and uses this object here, deployer, provided by here the Hardhat zkSync to deploy our contract, cars NFT, and so here it loads the artifacts, and here it deploys the smart contract, and it logs at which address has been deployed the contract. So if you want to run this, we need to execute npx-deploy zkSync script dash dash script deploy.sync dash dash network abstract testnet. Okay, so our smart contract has been deployed at this address. Okay, and we can check, for example, in the scan, abstract scan testnet, for example, abstract block explorer. Okay, if we check that address, okay, we will see that this is my address, so this is the address of our smart contract. Of course, the contract code must be verified, and if we want, we can verify the code so that here it is possible to see it. So we can run, for example, no, let's copy here this address. Okay, Okay, so our smart contract has been verified. So we can go here. If we refresh, we should see the code. No. Let's go to this URL. Ah, no, sorry. It has been shown here. Okay, perfect. Now we can see the code. This is our smart contract, and here all the contract that inherits are also visible, so everyone can interact with our smart contract. Beautiful. So now we want to interact with our smart contract. To do so, we will create another script. Let's create a new folder script. Let's create another file here, interact.ts. Okay. Now the code that we need to use is this one. So this is the address of my wallet. Here we need to put this address here, which is the address of our smart contract. So here we get the signer, we get the smart contract, and then the first thing to do here we can, for example, let's comment out this code. Let's see if we can call the name function, because each ERC-721 has a name function that should return the name of our smart contract that we have put here when we deployed the smart contract. So let's run here, for example. I don't know why he's not seeing the file. Let's try again. Okay. No. There is a typo here. Rename scripts. These scripts. Now it should go. Okay. The name of our contract, it is Cars NFT. Okay. Perfect. Now the first thing that we can test, it is, for example, we want to mint a new NFT. We can do so by running the SafeMint function. We pass the address that we receive our new minted NFT, which is my address, and the URI. This can be anything. Here I am passing a simple string, but you can also pass an IPFS URL where you have deployed your metadata, whatever. Let's run this. Okay. So it has it should have minted a new NFT. Let's check in the Explorer. Okay, 16 seconds ago, we called the SafeMint function. Okay, here it has created the new token of ID 0, and it has been minted to, this is my address here, you can see 368. Okay, now let's get back and try to see, to test if here we can see if my address, which is obviously always this one, as effectively as one NFT, which we have already minted, and also we want to see the token URI of the NFT of ID 0, so the NFT we have minted. So let's run this code again. Okay, perfect. Now we can see that the balance of my address is 1, and the token URI of the token 0, it is a URI of car number 1, which is the string that we have passed here. So that was the end of the tutorial. I hope that it has been useful. If you have any questions, please drop a comment below. Thank you for watching this video and see you in the next one.